All right, time is precious, so we're going to get started. Welcome to Best Practices Are the Worst. My name is Colt Blackmore. My lovely co-host this evening is Garrett Hamilton. By our powers combined, we are we're not Captain Planet. We are the co-founders of Reach Security. I'll introduce Garrett. I'll save his little talk track for later. Garrett has spent the bulk of the past decade at Palo Alto Networks, where he did lots of crazy, awesome things. You can go and read about them on LinkedIn. We're not going to get into any of that stuff today, because this poor guy also got saddled while he was there with best practices and compliance programs. So he has some pretty strong opinions on this particular topic. I have not been nearly as faithful to my employers as Garrett has. So I've bounced around from Palo Alto to Cylance to Proofpoint, and I've also never been stuck with compliance from like a program management perspective. But I do build things by writing code. So I can say quite confidently that there's more or less nothing worse than having to follow some best practice or hit some compliance target that makes the thing you're building less secure. Like that's pretty much the worst. So Garrett and I now are at Reach Security. We're not going to get into the ins and outs of what Reach Security does per se. That's not the subject of today's topic. You could kind of roughly think of it as the opposite of best practices, which is not the worst practices. That'll make more sense as we go. You'll get at least a little bit of a glimpse into the kind of stuff we're doing. So best practices. What are they? Like, what do we actually mean when we say best practices? As in, are these the practices that are the best? As in, there are no better practices, there's nothing else out there, like this is the be-all, end-all, that's it? I don't think anybody actually thinks that that's the case. I think if we went around the room, did a poll, the vast majority of you would at least agree that best is one of those words that like marketing type people will shove into just about anything and hope that it sticks in people's heads and that they tend to like associate something with the best. So I'm not trying to start beef, like with any of you mayonnaise lovers, for example, but best foods is not the best food, and best practices are not the practices that are the best. So if best practices aren't the best practices, what are they actually? Well, there are a lot of different definitions that we can consider here. So I'll give a simple one to get us warmed up. Best practices are shortcuts. So if love means never having to say you're sorry, here, best practice means never having to think about what you're doing or why you're doing it, because somebody else already did that work. Like they flexed their big monkey brain, they wrote some white papers, they went out to security conferences, they gave some talks, and now nobody gets to question the value, the security expertise. They don't get to question the wisdom of this thing that has now been enshrined as a best practice. It is, and so you have to do it. There is an upside to this, like if some executive comes running up to you huffing and puffing about something you're trying to do, you get to hold up your hand and say like, sorry, Skip, there's nothing we can do here. It's a best practice, we got to do it, and shut that down. But half the time, maybe more often than not, a lot of these best practices are net negative as far as your security goes. So for example, passwords. I refuse to believe that there's a single person in this room that's not annoyingly familiar with this particular case. Passwords. Passwords are super important, and like all super important things, that means they need rules. And so a long time ago, in a cubicle far, far away, the good folks at NIST, the National Institute of Standards and Technology, put together special publication 863. And in SP 863, they included an appendix. That appendix is basically a little primer on information theory and password security. What did they put in there? Like a lot of fancy stuff to try to make themselves look like super smart mathematician type people. So like they talk about entropy and randomness and guessability of passwords. And they even threw in an equation, which is a slightly weird way of writing it, but I'll allow it, for how to calculate entropy. This is very stupid, by the way, because if you know what a byte is, I can explain entropy to you in plain English, and it's very simple. But they put all this stuff in there to try to look like, security ballers, basically, back in 2004. And it went horribly wrong. So within a year or two, the whole world very quickly realized that it's terrible. Like these things they're recommending are terrible. What were those things? Well, users need to use uppercase and lowercase letters. They need to include special characters. They need to include numbers in all of their passwords, no matter what. So you don't get to control it. We're going to make you do all these things, which of course just leads people to choose less secure passwords because that's human behavior and you're not going to change it with rules. And the other requirement is that they had to rotate passwords frequently. 90 days was not a hard requirement from Appendix A, but it's kind of what people settled on based on the calculations that were in the primer. Some places do 90 days, 30 days, 180 days, but it's still very, very common. So even though we all realized it was bad, we're kind of stuck with it because NIST is NIST, and when they say jump, everybody else says how high. You think about the talk that was going on in this room right before us, it was about PCI DSS. Even though 13, 14 years later, NIST comes back and says, hey guys, all that stuff we said before, it was kind of dumb, don't do that. Even now, many years beyond that, you'll still see a lot of this stuff pop up in things like PCI DSS because it was part of NIST, and the lag time for correcting all of these really silly things is quite long. So maybe in 10 more years, we'll be free of this garbage, but for now, we still have to live with it. So what is the lesson here? I think it's pretty simple, and that is, when it comes to security, like be naive, channel your inner child, ask why. Ask lots of questions in general. Some would even say that this is a sacred obligation. Never thought I'd get to drop Heidegger in a tech conference, but I'm very proud of this. Thank you all for showing up. I'm not actually done yet, but still. So ask questions, take nothing for granted, right? Be naive, be, in a word, thoughtful. So that's the first definition, right? First definition of best practices is shortcuts, but if we want to be a little bit more eloquent about it, it's the outsourcing of, what is it the outsourcing of? It's outsourcing of thoughtfulness, if we want to be fancy about it. But there are a lot of other definitions. So we're going to run through a few, and Garrett, what else we got?
All right, clicker. We asked for 2 mics, and so we're just going to keep on to this handoff for the remainder of this. Promise we'll try to get better at it. So categorically, best practices, we're going to be talking through a few of them. One of those is the bare minimum. Going into this, we didn't realize that so many speakers, including the keynotes, were going to completely slam multi-factor authentication, but we are too. So we're going to talk about multi-factor authentication, what the bare minimum looks like, and why not talk about how multi-factor authentication applies to phishing. So assuming all of you are practitioners in here, I'm going to blast real quick through a rudimentary example of phishing. Phishing starts with an email. Okay, we're all on the same page. URL comes in the body of the email, kicking it old school, comes through a password encrypted document with the passwords in the body, whatever it might be. URL's in there, victim finds a way to get to it. Gets redirected to a compromised WordPress site. Why so specific on compromised WordPress site? About 10% of the attacks that we observe from customer environments when we analyze their threat telemetry use compromised WordPress sites as part of the attack chain. Hint, hint, if you're thinking about best practices, maybe go and look up how you might be able to identify WordPress in your network traffic and other places. All right, URL talks about cheese, that's why I chose this one. The other reason why I chose this one also is because it uses SharePoint. So let's imagine the victim is going through Office 365, trying to log in, passes credentials to that fake Office 365. Where does multi-factor authentication come into play? Right here. This is the place where best practices from Jamf to AWS to the 20 other vendors you can look up right now in best practices will tell you multi-factor authentication is the end-all be-all. Just deploy it, it's going to be awesome. But somehow we have attacks in the news where they had multi-factor authentication in place, and the hacker man here himself is able to get into the organization. So hopefully by the end of the day, you've realized that multi-factor authentication isn't the end-all be-all, kind of a spoiler for our conversation here. But the reason why we say best practices are the bare minimum is because if you just did what they told you, meaning the vendors or the man, told you to do when it comes to deploying security and stopping phishing, you would have stopped likely at multi-factor authentication. And this idea of being thoughtful through security is not to think about one single type of control or one single type of technology and how to stop threats, but it's how to think, how can we use all of our tools in place? So I'm going to get into that. Before I do, I have to bring up Baldwin, and we have a saying here at Reach, which is always be cogitating. If you've seen this movie, I was just told by somebody who was 30 years old. I was like in diapers when that happened, but it's always be closing in the sales world, but here it's always be cogitating. So let's be thoughtful about how we can prevent phishing. Now, we talked about how multi-factor authentication doesn't actually mitigate phishing. If you don't trust me, we can talk about the different ways multi-factor authentication gets applied. SMS. I can think of 3. Can anybody think of more than one way to phish SMS authentication codes? SIM swapping, calling T-Mobile and saying I'm you and convincing them to give me the authentication code, and man-in-the-middle attacks. We have the push notification. I guess there's push notification fatigue now from what I'm hearing. So there's that. And then you have the hard token. And the hard token is probably the best way to mitigate phishing risk. Don't know how many of you have actually deployed hard tokens. They're expensive. We have them, but we're a small company, so it makes it a lot easier. But obviously, if you can do that in a more focused way, that's beneficial. So multi-factor authentication doesn't stop phishing based on the news. Well, what is it good at? Because we don't want to rule it completely out. It's good at stopping brute force attacks, credential stuffing, that's what that one means, and password reuse. So if you're using something like Have I Been Pwned to check out passwords inside your organization, we use it for our infrastructure. And when you create an account at Reach, we will check it against a database of known compromised passwords. Those are all things that are helpful, but it's not helpful at stopping the credentials from being phished. So how do we approach this problem? Well, we won't rule out products like Okta. I'm going to talk about vendors now and how they can actually work together and help. Push notification plus number challenge. If you're not an Okta customer and you use Azure, as an example, conditional access, you have these capabilities available to you as well. That 1 to 2 seconds you might be able to apply to a user as they try to push that apply or that OK button, and you introduce a number challenge on that. So that's at the credential passing. Now, what about the entire attack when HackerMan has access? Stop them from logging in from places that you don't support as an enterprise business. There's no best practices that say don't allow people to log in from not proxy anonymizers, but there's literally a switch in Okta that you can turn on to stop that from happening. There's a switch you can turn on to stop them from logging in from Tor. I've only heard one customer come up to me or prospect come up to me and say, oh, well, we need Tor. And that person's sitting up here in the front. You can ask him later on what the requirement was. But I was told they needed it for a reason. You probably don't need it from an enterprise security standpoint. And last but not least, let's assume that from your threat modeling, from your threat-informed decision-making, let's assume that they already have the password, that they have the token they're now in. What can you do? Let's pay attention to where they're logging in from. A lot of these attacks come from the cloud. I picked on Alibaba. Sorry if you're an Alibaba user or you're a rep from Alibaba. You can actually stop them from logging in from specific CSPs or cloud service providers. If you see this connection coming in and you see it coming in from a new device or new region that you never recognized before, you're now able to apply security controls and boot them out, troll them, reset their session, and have to have them go through the entire process. It buys your operations teams time from an alerting standpoint to look at that alert. It buys your user more time to approve that notification one more time and on their side. But what I'm getting at is we talked a lot about MFA and SSO. I didn't want to leave them high and dry. There are advantages. But when we think about stopping phishing, we have to think about all of the steps. And so here at Reach, we think about how can you use email security. It's not just about the categories of saying this email is bad or this email is phishing, this email is malware, but using things like URL rewriting. Again, things like safe linking in Microsoft can also be used, or safe attachments can also be used with Microsoft. Applying those for attacks that might be unknown initially to the vendor. So don't rely on the vendor getting it right the first time. Give them time to figure it out. That enables capabilities like browser isolation. So one of the things we do here at Reach is we actually enable customers to focus on where might you apply these types of new security controls to start. Saves you money on licensing, for example. If you're looking at browser isolation, where are the 500 people you want to deploy it to versus maybe 5,000 in your business. But being able to say, for all those URLs that were rewritten, I want to proxy and isolate that traffic and stop the phishing from ever occurring, them ever arriving at the WordPress site as an example. Okay, so what else can we use? How many of you are using an EDR product how many of you use an EDR to stop phishing or detect phishing? Hell yeah. That's more, like statistically, that's more than we actually hear from folks. So even 3 out of this room is really awesome. I'd love to talk to you about how you're doing it afterwards, but Sentinel-1 and a number of other products, Microsoft just released some capabilities native. You can actually identify URL traffic and also domains, but that's not so useful in this case. Using something like Sentinel-1, you can take that same approach to saying, I want to look for compromised WordPress sites. Reach creates these rules for you automatically. You do your threat modeling exercise and make some threat-informed decisions to figure out exactly how you're being attacked and identify what sites are most nefarious inside of your business. I want to go ahead and identify WordPress sites that could be used with credential phishing and look at forms, for example, that could be submitted to. If I do that correctly, I have my most attacked people from a phishing standpoint receiving this type of policy, and I'm able to now step in at the redirect where I arrive, as well as submission of credentials. I introduce a new concept, because this again is about thinking through your threat model, thinking through your attack exposure as a company. One of the things I talked about products, one of the things you want to be mindful of too is where do the risk hotspots live inside your business? Do you know right now for certain, not like my executives are most attacked, because that's what we hear, and that could be true. But do you know for certain who the top 20 people inside your business who are most attacked and most at risk if they were compromised to hurt your business? If you don't, go figure it out and start to tinker and play with applying more stringent or strict security policies. You have a net new security initiative like hardening MFA and SSO. Go focus on rolling out to those folks first. We do all that modeling on our side, so we have most phished, most attacked overall, most impacted by malware, list goes on and on. But thinking about the human aspect and how you protect your workforce and how you apply those controls is really important and gets you to actually pick up speed. We find that about 3 to 4% of the population in a given customer environment can account for between 70 and 80% of all the risk or the attacks inside the business. Think of attacks not just in volume, because spam doesn't mean anything and stealing Netflix accounts is so what, but think about risk in terms of also the attackers and what they want to get out of the attack itself. Last but not least, I spent 7 years at Palo Alto Networks, so I'd be remiss if I didn't include them. This capability rolled out about 4 or 5 years ago. Almost no one deploys it. If you have Palo Alto Networks, go check it out. If you're afraid of deploying it to everybody, try it on some of those risky users inside of your business. But this will go ahead and actually prevent the post of credentials to websites. So if you're using SSO, why should credentials have any other path to the internet than, for example, SSO itself? Pay attention to unknown categories, categories of high risk, or just do it for everything depending on your threat model, and prevent your users from posting enterprise creds to websites that are, well, just any website, or they're unauthorized. Prevent them from doing that. There's a bunch of technicality on how this feature works. Happy to explain it afterwards. I think there's probably some Palo Alto Networks people in here that can also explain it, but highly valuable. So what did we just discuss? We discussed that the best practices tell you multi-factor authentication is the end-all be-all for that stage where I just got this, so I'm gonna use the laser pointer. End-all be-all for stopping phishing. When in reality, it's just a speed bump, evident by the way in which we're seeing attacks happen in the news. When you think about how to prevent a phishing attack, it's much more complex. I just spent 8 minutes talking about it, right? There's so much more that you can do in terms of how you want to approach stopping phishing. So in your threat-informed decision-making, think about how all the products can work together. That is why best practices on their own are the minimum. So Colt is going to talk about another category of best practices. This one's going to go more into the dev side of the world. So, let's see what happens.
This is terrible. All right. So best practices are also one size fits all. Another way of saying this is they're good, but like on average. As a data science guy, this is the one that really churns my butter. So let's say you wanted to get like a really nice suit or a really nice dress or whatever you like to wear. Do you want something that was made for the average person, or do you want something that was tailored for you? It's kind of obvious, right? If you go and take the measurements of 1,000 people and you build or make some article of clothing that's the average of all those measurements, it's actually very unlikely to fit any of those 1,000 people because it's just an average across all of them. That's the problem with averages. They don't actually fit anyone. It's just a generalization across the group, and it's not super helpful. So why am I talking about this? Well, let's look at an example. AWS. If you build things in AWS, you will probably have encountered AWS's best practices for IAM, Identity and Access Management. There are 14 items on the list. You can Google this and find them. We care about a couple of the top 3. Like these are the ones that AWS says are most important. So here's number 1. Require human users to use federation with an identity provider to access AWS using temporary credentials. Not very well written, but there are 2 key concepts here. One of them is federation with an identity provider, which we all just call SSO. There's no need to be fancy about it. And the other is these temporary credentials, because you can also use credentials that are static and last forever. So that's one. And then third on the list, which is an addendum to that, is require our old friend MFA. Garrett did a perfectly good job of deconstructing MFA. We don't need to dig into that more here. We just need to, again, channel our inner child and ask question, like why? Why are these best practices? What is the concern? What's the hesitation? What are people worried about here? They're worried about this and the 1,000 incidents just like it that have been happening for the last decade, give or take. So this is just a couple weeks ago. Toyota comes out and discloses that somebody over there had accidentally committed secret keys to accessing their cloud infrastructure into a code repository that was publicly visible, happened to be uploaded to GitHub. And as a result of that, several 100,000 customers' data was exposed. It's kind of a big deal. Oh, and by the way, all the bad stuff here, it happened 5 years ago. So they exposed the keys 5 years ago, and then just now realized it, was it October 7th or whatever? Yeah, October 7th. That's a pretty long window to have those things hanging out there in the wind. So not very good. So how does a data leak like this work? Pretty straightforward. You've got an engineer who builds stuff by writing code. Hello, nice to meet you. And some of the code that engineer writes is going to go up into a cloud like AWS. And in order to access and interact with that cloud, they're going to use secret keys. You can think of these as like passwords, but for machines. So they don't have the same flaws and foibles as human-generated passwords. They're much more secure, but they're still basically passwords. So you have those, and by default, they're static. They don't change, they don't expire. But they are assigned directly to the identity of a human. And now what can happen is, if that engineer is, let's say, inexperienced, or the development team just has piss-poor practices, they can accidentally end up committing those or commingling those secret keys with the code so that it ends up in the code repository, let's say Git, Mercurial, something like that. And then it gets synced up in some cases to a public cloud, which GitHub is an example of. But that's not the only way things can go wrong here, right? You could also just have a CI/CD pipeline that runs locally that picks up those secrets because now they're in the code and builds them out and deploys them out to a customer. It could be a React app, so it's deploying like a front end through the browser. It could be a local application like Microsoft Office. It could be a million different things. But either way, the secret keys that give access to production and all your customer data, those get exposed, and now the return of HackerMan. Not a great situation. Now the theory here, the reason AWS has these best practices, watch the little key there, because this is stupidly subtle. Terrible slide choice by me. By making these keys temporary, we cut this whole problem off at the knees. Like, we're not going to eliminate it entirely, but we do dramatically reduce the problem there. And the idea is this. You still got the engineer. They might still be inexperienced. They might still be on a pretty crappy development team doing stupid things all the time. None of that changes. But now, in order to get their access keys, they have to go through SSO. And they do that in the same way that they would check their email or go into Workday to request time off or any of the other billion things you do with your enterprise corporate resources that are managed by SSO. The far side of that process now gives you back the temporary key. And so, okay, maybe this key still gets committed to code. Maybe it still ends up in GitHub, still gets deployed through UI, anything like that. But the key's temporary. It is only good for like an hour, or if you're really not mindful of security, maybe you allow it to live for an entire day. But usually it's between 1 and 8 hours is what most people do. And that means you're kind of okay, right? Like, you leaked the key, HackerMan is maybe still there. If he finds it fast enough, he might be able to do something with it. But if you do everything else correctly so that there's no escalation path once they get into AWS, you're kind of in an okay state here as far as this threat model goes, right? That's the idea. People think, at least. But that's not true, at least not exactly, because what did we just do? We added phishing to a threat model where it did not exist before. Like, static keys, okay, they have problems, they can leak, you can expose them in source code, whatever. But what do we already know is like the single biggest attack vector on companies around the world? It's phishing, and you just added it to the authentication path for your production systems by following the best practice. I'm not saying you shouldn't follow the best practice, but I am saying that there are trade-offs here, and you have to think about them very, very carefully and understand the risks that you're accepting when you make a decision like this. It's not a one-size-fits-all decision. But this isn't even the only bad thing. We also introduced several new attack surfaces that did not exist before. What do I mean by attack surface? For example, centralized access. Access is compromised. Like, you phish someone's account, you compromise them. That's what access is. When you centralize access, you also centralize compromise. What I mean by that is, if you're running everything through SSO, then I could phish your Office 365 account, and if AWS production is part of SSO2, I can jump from your email to production like lickety split. There's nothing getting in my way there unless you go out of your way to implement extra controls. That's very problematic. And if I get somebody who's like IT or security, engineering, which doesn't maybe happen as often, but we know it happens. Just ask the folks at Uber from like a month ago. Like, bad stuff does happen. Now I can pivot like anywhere. I can get into your SentinelOne or your CrowdStrike or your firewalls or a million other things, shut all your security down. Like, I can open you wide up like you are a patient on the operating table and I'm the surgeon. It's bad. It's really bad. So again, I'm not saying don't use SSO, but be aware of the risk that goes along with this. not something we need to dwell on, but there's a supply chain risk here too, right? If you're delegating authentication to your systems to somebody, third party like Okta, you have to worry about them getting breached. And of course, what happened to Okta in January of this year, they got breached. They didn't handle it that well. It's a whole thing, you can read about it online. Again, don't need to dwell on that. Much more interesting, cryptographic doom. This is a phrase from Moxie Marlinspike. If you use Signal on your phone, it's one of the guys who developed all that stuff. Very important in the context of SSO, because what is SSO built on? Cryptographic protocols. What do we know about those? They're very, very hard for people to implement correctly. When non-experts do it, there's a 100% chance it's going to fail, and it's going to fail catastrophically. And even when experts do it, there's still like a 98% chance that it's going to fail, because it's just almost impossible to do well. So when you accept SSO, you're accepting this risk. I get pushback on this from basically everybody when I talk to them about it, even my own team at Reach. But let's look at some actual numbers here. So you might say, well, SAML's been around for 20 years, right? That's one of the protocols, security assertion markup language. It's been around for 2 decades. The kinks have probably been worked out by now. That is absolutely not the case. We don't even have to go back that far. 2018, the research team at Duo found just a complete blanket vulnerability across essentially every implementation of SAML that was out there. It affected every company. You could use this to log into the SSO accounts of basically any person at any company in the world. Like one login, ping, Duo itself, Okta, all were affected. Okta also lied about being affected. They got blasted for it on Twitter. I definitely recommend looking it up because drama's always fun. But it's just really, really bad when this stuff goes wrong. And it lays the entire company bare because it's authentication. And have things been like good since 2018? Absolutely not. 2019 to 2022, we see still thousands of these things. There was one, like the day I made the slide, there was a new one, which I thought about putting on it, but I didn't. So there's just a ton of stuff. And it's not like these are open source developers, like hobbyists. Like these are the companies you really, really trust, right? Palo Alto Networks, Microsoft, they're a big deal. SAML's not the only one. The much more widely deployed, although younger example going on right now is OIDC, OpenID Connect, built on OAuth. That thing is everywhere. If you've ever logged into something through Google, logged into something through Facebook, OAuth, OIDC. Same exact problems as SAML, it's just based on JSON instead of XML, but otherwise it's pretty much the same stuff. And it's a disaster. So again, I'm not saying don't use it, I'm not saying don't do it, but understand the risks, what all the factors in play are, and like make an informed decision is the idea here. I would say kind of my hot take on this whole thing is centralization is okay. Obviously, there are upsides. It improves manageability. So it's great for IT in that sense. But for security, if you can, keep something separate so that at least there's no pivot from checking email to accessing the most sensitive financial records of the company or production engineering or any of these other really sensitive things. Just my hot take. If you do want to centralize stuff, though, you do kind of have some options. So in the vein of cryptographic doom, there are things you can do. Okta has basically webhooks, for example, that they make available. We're not going to get into the details. They're kind of technical. But if you're interested, come by the Reach security booth like tomorrow. I'll tell you what we do in Reach to secure Okta from itself so that even if all of their stuff breaks, our logins are actually still secure. It's possible to do it. It just requires some work. So these things can be done. So that's pretty good. The good news is all the stuff that Garrett talked about, you can also still do so that even if you have SSO risk, you have cryptographic risk, you can still lock things down as much as possible to keep them reasonably secure. I'm not going to talk about the same examples Garrett did because those are examples of how Reach protects customers and the things we look at and recommend there. But another cool thing we did with Reach, basically the first thing we did after we built it, was point it out itself. So these are examples of how we use Reach to secure Reach. These are the kinds of things the engine thinks about when we present it with security data and give it a problem to solve. So I'll give you 3 options for the AWS example. Option number 1, MFA. We've been crapping on MFA for like the last 20 minutes, like why are we mentioning it now? There is that one form of MFA that is actually quite effective against phishing, and that is WebAuthn. It's not entirely correct to say that it 100% blocks all phishing all the time. That's actually not true, but it's a reasonable approximation. Like it's basically the truth for any threat model you really care about. So there is that, and if you're willing to do it, it's super useful. You don't need to do it for the whole company. If you have 1,000, 10,000, 100,000 people, like that's a lot of hardware tokens, for example, to manage. You might not want to do it. Nobody's going to blame you. But there's probably between 2 and 5% of the company that actually has the super sensitive access that you care about. So just do it for them. You can assign them based on people groups to find an Active Directory. You can assign it to the sensitive apps. You have options. So you can lock those things down and make them more secure. That's the best option if you're willing to do the legwork. But we got a couple more. There's also separating the apps in single sign-on so that the single is no longer a part of the equation. So you can make it so that somebody can go log in, check their email, and then when they try to pivot to a different application, different resource, they still have to log in again, even if they just did it 5 minutes ago. You can always require a login, always require MFA to that other thing. That is not going to stop them from getting phished on either side, but it will at least shut down the pivots from Office 365 or SharePoint or whatever into the sensitive data. So it's somewhat useful. But you can also take this a step further. You can say, add an additional factor. So maybe everybody uses Google Authenticator, one-time password, OTP, to log into stuff by default. But for the sensitive resources, now they got to do something else. They have to do Okta Verify push notification with a number challenge or something like that. It's both effective in an absolute sense, and then also just as sort of a side effect of the way things work. Most attacks are going to be completely broken just by the fact that you have a third factor, because the attackers weren't planning on that. It breaks all the assumptions that they made in their attack, and so it ends up just kind of working twice over, which is handy. So again, super useful options. Now, none of this stuff is a shortcut. It's not, what was your thing? Yeah, what was your, yeah, it's not a bare minimum. That's it. It's not a bare minimum, and it's not one size fits all. It's tailored. It's looking at your specific risks, understanding your company, choosing the right options for you. And so if we were gonna hazard an actual best practice, it would be don't use a best practice, measure, cut, like do the right thing for you. But there is one more. Are we in time? All right, we're just gonna keep going. There's nobody after us, so we can ride this thing till the wheels come off. It's all good. One more thing, not super serious. Well, it's super serious, but it's not super serious because there's not a ton that you would potentially do about it. Best practices are Big Brother. You may be familiar with this example, you may not. It probably depends on how closely you followed all the Edward Snowden stuff when the data started to come out of that. But in the early 2000s, the NSA kind of wormed their way into a standardizing discussion around a new random number generator. You may have heard of it. It's called dual EC DRBG. It's a dual elliptic curve deterministic random bit generator. This is like, I think it became standardized in 2004 in ANSI X dot whatever standardization body. So they went to a lot of trouble just to get it standardized. And then they went over to RSA, which used to be an important company. I actually have no idea what they even do today, but they used to be kind of a big deal. And they paid them $10 million to make this random number generator the default for BSafe, which was kind of the industry standard for FIPS 142 validated cryptographic modules, which if you do any government work, like you know what a pain FIPS is and you've experienced this. If not, just understand that cryptography is always a pain, but it's particularly a pain when you want to sell to the government because they have requirements. Governments are weird like that. So they paid RSA $10 million. They got it in there as the default of BSafe. And there was a period of like, I guess it would have been 9-10 years, where in theory, because they controlled the random number generator and therefore could predict what random numbers were going to be generated, they could decrypt all the traffic, they could do whatever they want, that stuff, and complete visibility into anything. Most interesting fallout from this whole thing was that Juniper was actually affected. So at one point, all Juniper, well actually for like a decade, Juniper firewalls were backdoored and the wrong person could decrypt all that stuff, which is super fun. That's what you want from your security vendor. So that's it for us. Jason, take a picture. Even though there's no light, it's not gonna be a very good picture. Get up here. You want this slide? Pulp Fiction slide. Everybody loves Pulp Fiction. If not, get out. We don't want you here. All right, that's gonna be dark as hell. If you have questions, of course, we're happy to talk more best practices, come up to us after, that's fine. Otherwise, thank you for showing up at the end of the day. Hopefully you're a little more awake than we are right now. And come find us at the booth. We're in number 4, one floor down. We'll be around until the thing closes. Thanks, guys.